Hey there, game devs! Have you ever wondered why your game slows down even though you got a beast of a GPU? The answer often lies in understanding what happens behind the scenes. And by that I mean understanding how your CPU and GPU work together in Unreal Engine's render pipeline. You see, your computer is like a game studio, with two main teams, the CPU, which does all the thinking, and the GPU, which handles the visuals. The CPU has two major responsibilities here, the game thread and the render thread. Together, they make sure your game logic and visuals are prepared before sending everything to the GPU for rendering. First up, the game thread. Think of this as the programmer of your game studio. They handle all the calculations like physics, spawning, AI, and game mechanics. Their job is to decide what's happening in the game world. But if they have too much to process, like hundreds of NPC running complex behavior trees, they will slow down and make the entire game feel laggy. Next, we have the render thread, which is also part of the CPU. This is like the project manager of your team. The render thread doesn't create anything itself, but it organizes all the information from the game thread and decides what gets into the CPU, GPU for rendering. Think of it as deciding what's visible and what isn't. If the project manager has too much to juggle, like managing tons of lights, shadows, or unnecessary objects, the pipeline slows down. And finally, we have the GPU, the artist. The GPU takes all the instructions from the CPU and transforms them into stunning visuals you see on screen. They render the textures, calculate lighting, and apply all these fancy post-process effects. But like any artist, the GPU can only handle so much. If you ask it to do too much, like rendering thousands of dynamic shadows or high-resolution textures, it will struggle, and your game frame rate will tank. So let's break it down. The game thread and render thread both run on the CPU. They handle the logic and organization. The GPU handles all the heavy lifting when it comes to visuals. If the CPU can't keep up with the GPU, or the opposite, you will see performance issues. That's why it's important to understand how these roles interact. So, why does this matter? If the game thread gets overloaded, it slows down everything. No matter how powerful your GPU is, if the render thread is overworked, the GPU won't get the instructions it needs in time. And if the GPU is overwhelmed with too many tasks, it can't render frames fast enough. It's all about balance. In this video, we are going to break down how to identify these bottlenecks and optimize your game. I will show you how to profile your project, pinpoint the problem areas, and take your game's performance to the next level. Ready to level up your optimization skills? Let's dive in. Alright, let's talk about profiling. Because finding bottlenecks is like being a detective for your game performance. Here are the tools that will turn you into Sherlock Holmes for Unreal Engine optimization. First up, Unreal Insights. Think of it as a time machine for your CPU. It records your entire play session, showing you what's slowing down the game thread or render thread over time. Perfect for uncovering sneaky CPU bottlenecks. Then there's the GPU Profiler, a laser-focused tool that grabs a single frame and breaks it down to show what's overloading your GPU. It's like a magnifying glass for rendering issues. Need to see the bigger picture? Check out Optimization Viewports. They let you switch between specialized views like shader complexity or overdraw to spot inefficiency at glance. Don't forget stat commands. These are quick console commands to give you real-time stats. Just type stat unit or stat FPS to keep tabs on your in-game performance. And if you want to go beyond Unreal, there are external tools like RenderDoc, NVIDIA Insights, AMD Radeon GPU Profiler, and Intuit GPA for deep dive profiling. With those tools, you will know exactly where your game is lagging, and more importantly, how to fix it. So let's start optimizing. So before we go more in depth about the render pipeline and study a bunch of theory, I want to show you how you can optimize a project in real time and show you some problems that you can have in your game or project and how to profile it and how to resolve them. So I have prepared this Unreal scene myself. This is a scene from the marketplace, and I have artificially created some issues that we're going to solve, and I'm going to show you how they affect the CPU and GPU. So first off, as you can see, there's this thing preparing mesh distance views here. If we want to remove this, and because this can actually affect our performance, what we can do is go to project settings, in the settings, and in the search type Nanite. So if you're not using Nanite, you can disable this here, and if you don't know what Nanite is, just you can go and search about it. It's very good for some projects, but for the sake of this one, I'm just going to disable it. And it will ask me for restart. I will restart the project and be back here. So we're back with the project, and as you can see, there is this text, red text here: Nanite is enabled but cannot render, blah blah blah. So to disable this is not really something that you should be thinking about right now. And just to disable this so we don't see it, we can go to the command line here or press the tilde key. This is the key on your keyboard that is next to your 1 and under your escape key. So here we can type r.nanite, and we can say 0, and this will disable this. So we're done with the Nanite. So let's get into optimizing the scene. And even moving around in the editor, it's like super laggy. It's not really nice. And as I said, I prepared this scene for you so we can optimize it. The first thing we want to do is maybe you want to see the FPS. So let's go to the command and type stat FPS. These are the stat commands. There are a few of them. I will provide you a list with the most used one and what they do, but the stat FPS does what you may think. You will get the FPS, and the FPS is, let's say, not desirable at this point, but when you optimize your scene, what you're going to look is not the FPS, but rather this number here below it. It's MS, right? And we're looking at that because this is the actual thing that we need to consider. These are milliseconds, and for us to have a 60 FPS, we need to have about 16 point something here. And to have a 30 FPS, we will have 32 or 33, like here, right? And right now it's not really doing very well. So how can we actually know what is causing this? Is it the models, or what is going on here? And to do that, again, we will go to the command and type another stat command, which is stat unit. Very easy to remember. And now you have a little bit more detailed view of what is going on. So here we have the frame. This is basically the frame, the final frame, and it's not doing very well, right? It's the same number as here. And then you have the game thread, as we discussed earlier. The game thread is looking very good here. And we hold the draw. The draw thread is basically the rendering thread, but it's called draw here, so it's a bit confusing, but you can call it the draw thread or rendering thread. And the GPU time, this is the GPU, basically the work of the GPU. And these are the three lines that we're going to look a lot further and investigate. Currently, it looks like the bottleneck is the GPU. However, it's not very good to profile in your editor. So what we're going to do, the best thing to do is to build your game and profile the build. But the next best thing and a little bit faster to do is to go here, press this button here, the three dots, and play in standalone game. This will basically simulate a build, not exactly, but still. And I recommend you, when you profile, close everything else, because like Google Chrome or any other program can actually influence this. So let's try to open the game. And now that we have the game open, we can see the FPS and the whole gameplay is very lagging, and this is not really acceptable. So let's do the same thing. Open the console command and type start FPS and start unit. And as you see, it's actually worse than the editor. And this time we can see the game thread a lot worse than the editor. And this happens because, as we mentioned before, the game thread is responsible for in-game events, spawning of objects, physics, and blueprints. So something is not alright there. And we don't have AI here or much of animations, so I don't believe that is the issue. So how do we profile this? As you can see, everything is really red in the MS. The game thread, the draw is good sometimes. Look here. If I look like this, even the draw becomes very little because we're not looking at anything. We're just looking at the ground, and there's nothing much to organize that much. However, the GPU is also bad, but as you can see, the game thread is I released the bottleneck here. So how do we start profiling this? There is a few ways, but as you saw in the slideshow, kind of, the game thread, you can profile it with Unreal Insights. So let's have a look at that. We can close the game. And here we can try the Unreal Insights. So how do we open it? We go here, this, if you're in Unreal 5, here in this trace, so click trace, and here in the Unreal Insights session browser, you can open this. It will take a little bit to open, but it will open. So yeah, and here in this area here, this is all the traces you did before. And basically, the Unreal Insights, when you open your game, it starts tracing the whole process, and after you close the game, it ends. And everything in between, it traces everything that happens in your game. So I don't really need all of them, so I'm going to delete this, because we're going to create a new one. And to create a new trace, all you need to do is have this open. We can minimize it and open the game. And while we are opening the game, you will see that it's connecting to the server kinda, and you will see here that it starts tracing. So this is all the operations that it does before it actually opens the game. And yeah, now we have the game open. So let's have more in-depth look in this. So here, this is the timeline basically. So if we zoom out with the scroll button, you can see it's tracing in real time, and this is the timeline. The same as here. To zoom out and zoom in, just scroll. And let's say these are all frames that happens here. But as you can see, we have a lot of information. this is all the tracks and all that is happening, and it's a lot. It's like a lot of threads, a lot of stuff. What we can do is go to all tracks and just press here to disable everything, and what we're going to need here is the game frames, which is the game thread, the rendering frames, and GPU, game thread, and render thread. So these are the things that we are going to need, and now we can have a look a little bit easier. Here we have the game frames, rendering frames, GPU, game thread, so everything is here. And here we can see the render thread. So with the right mouse button, you can kind of pan like this, and with the scroll you can scroll. It can feel a little bit weird at the beginning, but yeah. And here we have all the things that are happening. For example, if I click here, you'll see it appear like this, right? So it keeps going, and I can just select a frame because everything is red here, and it shouldn't be red. I will show you at the end. You will see how this is going to look. But for example, I want to look at this frame, and if we zoom in, we can see the GPU, the game thread, the render thread. So we have everything here, and this is the render thread. As we can see, there's a lot of wait for. This is basically waiting. So the render thread is not really an issue here. The GPU is also doesn't look like the main issue, because as you can see, if you click here and you can see it here, it's like 73 ms, and here is like 155. This is the game thread. It overlaps a little bit from frame to frame because this is very heavy, but yeah, we can zoom in here and look at the game thread because we deduced that probably here is the problem, and we have something happening here. As you can see, there's different things that takes time, and the thing that takes the most time is this BP calculations. As you can see, this is a huge thing, and as you can see, if we zoom in, there's these operations in this BP calculation. So if I click here, you can see less equal. So this is some calculation, and in this frame, it happened 247 times. And you can see how expensive this is for this particular frame, because when we click here, we examine one single frame. This all here is happening in one single frame. It's a lot. So this is our culprit. It's very easy to find. So what is this? How can we find this? How can we find this guy? First off, we can just stop the game. We don't really need to trace anymore. I believe we found the game thread culprit, and we can try to resolve it. So in our level, we can type the name of this, and it's BP calculations from what I remember. Let's check again. It's yes, BP calculations, and we can see this blueprint here. It's only one in the scene, and this one blueprint is causing all these issues for the game thread. And if we open this, let's maximize. You can see it's very simple. There is nothing in here. Construction script is also empty, which construction script also can be very problematic, but in this case is empty. And what do we have here? So from what we saw, there are some calculations happening in the Unreal Insights, right? So less than equal, at, so we have a lot of this. And as you can see here, this proves to be true. There are some calculations happening, but the worst thing is that we're using for loop and another for loop inside the first one. It's called nesting, so we have nested for loop. And this is 500 times, and every single time is doing 500 of these guys here, of this for loop. So it's a lot. This is happening every frame because it's in event tick. Event tick happens every frame, so this is what the game thread is responsible for. One of the stuff is the event tick. So if you have a lot of stuff in the event tick, it will appear in the game thread and it will do something like this. Like we have 136 ms, which is insane. So what happens if we just remove it? Let's say this is not something we want for sure. If we just remove it and we play the game again, remember, always test in this standalone game, and we start the tracing again in Unreal Insight. If you open it, we will start the tracing again, and we're just waiting for the game to open. Let's see now. It should look a little bit different after it opens. It's doing the initial calculations here for the preparing everything for the game, and it opened, right? It's still red, but let's say if I walk a little bit to trace stuff, right? I walked, I saw, I look at that, and we can close the game because we don't need any more. And here, for example, let's go to this frame. And the problem was in the game thread, if you remember, like this. And currently the game thread is not really giving us any issue. In fact, the one thing that is in the game thread right here, we have again 124, but this 124 is not caused by any thing in the game thread, because if we see, we have wait for tasks. So if you see this wait for tasks, you basically solve the bottleneck, and there is a next bottleneck that we need to figure out. And again here we can very annoying, you can do it again to see it like clear. We can see the game thread is not really a problem anymore, but we assume that the next problem is the GPU, because now we don't have crazy stuff happening here, but there is something happening inside the GPU. And we have the shadow depths from what we see, and there is a lumen, so maybe there's a lumen issue here. But yeah, to have a better understanding of the GPU, what we can do is actually use the GPU profiler. So you can even do it here. I will show you how to do it. You can do it anywhere basically, but to open it, you press Ctrl, Shift, and comma, and you can open the GPU visualizer. So this thing takes a picture of your screen and shows you basically how much certain things costs. For example, the difference between this and Insights, Unreal Insights, is this takes one frame and the Insights records your gameplay. And this one, the GPU visualizer, shows you, well, as the name says, what causes issues with the GPU. And here we have lumen lighting and diffuse, indirect, and AO. We have again diffuse, and we have translucency. We have a lot of stuff here, but let's see lumen scene lighting. And there is something causing a lot of problems, and it seems it is with lumen. So this is the lumen one, lumen scene rendering, right? Sorry, lumen scene lighting. So we can assume it's something with lumen. One thing we can check for this is the lumen settings. Maybe there's issue there. Maybe we can check, we can fix it like that. And to do that, you can go to your post-process effect, and here you can check the global illumination and the reflection. As you can see, it's set to lumen, so maybe this is the culprit. And if we go to lumen global illumination, we can see there's some values here, and maybe you don't know what they do, but these are the basically quality settings for lumen, and they're not really in their default state. So let's see what does that one does. Scarce lumen scene quality. Large scales cause lumen scene to be calculated with higher fidelity, which can be visible in reflection but increases GPU cost. So this increases GPU cost, and I believe this one also increases GPU cost, and the same thing goes with all of them. So what happens if we just return them to normal? You can play around with this and actually optimize it further, but let's see if we return it, just return it to normal. We can already see there is some improvement here, and we can go to the reflections as well. So let's say someone from the team went and messed around with this, and now you can just return it to normal. And now you see the FPS in the editor improved, but let's go turn everything back to normal. So these are the quality settings. You can actually optimize it further. You can make this something like that actually, but it doesn't really matter right now. But these are the lumen quality settings. This is for the global illumination, and this is for the reflections. If you increase them, obviously the quality will increase, but as you saw, the FPS will decrease. So let's test this in our game. We will trace it again. It's a good practice to just trace it every time, because we solved one bottleneck, that is GPU, but maybe the next one is the CPU, you never know. But let's see. Now that we have the game open, we can see that the game is still not running very well. Let's see what's going on. Start unit, and we are having some issues. You can do start FPS if you would like to see the FPS, but yeah, the game thread is improved. The GPU is a little improved after we did the lighting, right? The lumen, but there is still issues here. There is still a bottleneck that we are not seeing. So what can it be? Let's bring the GPU visualizer, because as you can see, it's not the game thread anymore. The game thread is 5 ms, that's very low. So Control Shift and comma to bring the GPU visualizer, and let's see what's going on. As you can see, the lumen scene lighting is actually decreased. It was something like 14 or 15, and now it's like 5. It can still be improved for sure, but for now this is not the bottleneck. And we have translucency here and lights. So what is up with this translucency? Let's have a look, because from what I see, I think this is the biggest bottleneck. And yeah, we just have translucency issues. So there's something weird going on, right? So let's do, for example, like here. If you look at this point, you can see the GPU is actually pretty low, don't you think? if you look like this, the GPU increases to like 30 ms, and then you can look at this, and the GPU increases like a lot. And here we have something going on. So what can this be? This is some glow effect, and I believe this is causing our issue. So this is how you can profile your stuff. You can play around or look around and see what is causing the things. And sometimes it can be very visible like this. But another thing we can do is if we press F5, you can see this is the shader complexity. You can see the shader complexity is okay. There are some parts that are red, but nothing really white. But there is this light dot here, and it's not very good. So if you press the F keys, F5, F6, you can toggle the different viewports. But let's exit the game for a moment, and I can show you how you can another way to profile is with this called if you go to lit optimization viewport. So you have some stuff happening here, and shader complexity, if you see it, it's not really like it's a white square, but not really that much happening, right? But it's very strange because if you look at this thing, it has very high ms. So let's examine this. So we have this looping thing, and oh, okay, so that is not normal. Let's say we have 1, and we here have a spawn rate of 900,000 or whatever number that was, and it's just a dot. So what happens if I do this? It's a dot. If I isolate this emitter, it's still a dot. So basically it's a dot. We can delete this one because we don't need it. Maybe we need this dot here, so we have the same result, a little bit like it's not as intensive as before, but if you like it to bring it the same intensity, you can just go color mode and just have 100 or something. It can go, it is the same result, but with 1, and yeah. So now we have this dot here, and as you see, this is not still it's not optimized perfectly, but again the GPU is a lot lower. To optimize this perfectly, you can just do something like that, spawn burst, and it's the current duration, so it's infinite basically. There's other ways to do it as well, but yeah. You have the dot, very useful dot, and now it looks like the editor is not so bad, is it? The editor is running a lot better. But you can see this game thread here, right? So don't be too alarmed by that. This can happen because there is some overhead from the editor itself. So that's why it's good to like always test in the always profile in the game. But let's play the game. Let's see what's going on here. Okay, we have the game, but it's not looking very well. The editor was running better, but the game is still not doing that well. Top unit. So it's not doing very well here, is it? Even though we optimized up here, it's still not doing very well. So again, we have a bottleneck that is the GPU or the drone, right? It can be bought at this point. So how we can do it? We can do the GPU visualizer and look the next thing, right? So we have shadow depths and we have light. So shadow and light, I think it's connected. But it doesn't look like we have a lot of lights here. It looks like one light. So why is it causing that? Let's go to the visualizer and let's the GPU visualizer and let's go to the lights, right? Click here and just go, and you can see it's causing some issues. The shadow depths are also causing the issues, but let's go to the bottleneck, which is the lights. This is the one that causes the most, and you can do this, like organize it, and you'll see the bottleneck immediately on the top. So we have direct lighting, okay, so unbatched lights. So interesting, we have a lot of lights here, quite a lot. This is not normal because our level doesn't really look like it has a lot of lights. And if you remember, in the editor we did not encounter any issues like this. Like this is 15 FPS, yet in the editor it should be actually more FPS than here, like and not the FPS only, but the milliseconds. It's like ridiculous. So let's close the game and let's find let's try to find what's going on. So it said there is light, so let's go to the outliner and look for lights. There is not really anything that is right here. So what can be the issue? So we cannot see the lights in the editor, and to demonstrate you that you can actually not see any lights here, if we go to the viewports and go to light complexity, everything is blue. Everything is blue and there is nothing happening. So what is going on here? The GPU visualizer shows lights, but there are no lights. And if you do the GPU visualizer here, the lights, which is well, here it's like 0.39. So there is another bottleneck here. But if we do like this, you can see here, right? But it's not the lights. So what is going on? What can it be the issue? So we can try to guess what is the issue. Maybe the lights are spawned into the level when you play the game. Maybe it's spawned in the blueprints. If we open the level blueprint, we will see what is going on, but there are no lights spawning here. However, there is this load stream level by name, which basically loads a level, or basically a sub-level. So maybe we can go to the levels, and if you don't have this level here, you can go to Windows and just press the levels. And here we have some stuff, like we have the VFX. So I believe, well, I know what is it, so it's responsible for this guy here. And let's see what is this very badly named level. Yeah, I know. Let's open it and see what's going on. At first sight, it did nothing, but our FPS is very similar now to the FPS in game. And if I press G to turn off the in-game mode, we can see a lot of lights. And now if we go to lit, optimize viewport, and go to light complexity, yeah, this is happening. We have a lot of lights, like a lot of them, and all of them have this kind of radius, like, yeah. So this thing you can actually check and optimize without playing the game at this stage. So all we need to do is go here and type point light just to be sure. Select all of them, and we can see the settings here. So you couldn't even see them because the intensity is like 0.001, so they're doing basically nothing. At this point you can delete them, or what you can do if you want to use some of them, or this is obviously a very extreme case, but for example, maybe you have a lot of lights and you actually need them. What you can do is reduce the radius. For example, if we do 100, that will be like that, and our FPS will immediately skyrocket. So the GPU and the draw will not be will not have any, that much issue. There are still a lot of lights here, but most of them are not really affecting anything. And another thing you can do, the best thing is to delete the ones that are not affecting anything, but for example, maybe you like to have this light here, and maybe this is 7 or whatever, and you want it to affect just that. You can increase the radius, or yeah, and just have the ones that you need, but don't have a radius like this when you don't really need it. So for us, we don't really need any of them because they were doing nothing, but they were affecting the GPU. And as we saw, you can literally see the name of the lights in the GPU profiler and see what is the issue. And if we delete them, now the FPS is a little bit better. So let's play the game again. Save. So we are back in the game. The game is running a little bit better, I would say. That's understatement. It's running a lot better. Let's see stop FPS. We're having a 40 FPS now. And yeah, there are some issues. You can optimize further. Of course, you can optimize Lumen. Lumen is taking a lot of my memory right now, but yeah, it's running well for now. So we have this gun, and let's say the gameplay was to shoot, and let's just shoot the gun. And we immediately see there is something wrong with this. Let's do start unit. And first explosion is obviously something wrong with it. It looks like it's spawning a lot of things at the same time. A lot of things. But also, even if the explosion is over, as you see, the game thread and the draw thread are still very heavy, very expensive right now. And if we do this a lot more, maybe we can even crash. But the more we do it, the worse it gets. So it's obviously something with the VFX, and rather than the VFX itself, it's actually with the spawning VFX, because the game thread is responsible for the spawning of objects. So let's see the insights, right? We record this, and as you see, let me open this like that. As you see here, while it's not really good, it's not the best thing, and we can go into it and see what is causing the problems. For sure it's the GPU, because we have some lighting. This is Lumen, yeah. Lumen can be optimized, but after we started playing, there is this insane red thing going on here. Let's do this again. Game thread rendering GPU and render thread. So let's see the first one. Let's see this one. So again, this is in the game thread, and you will see what the game thread is responsible for very easily here. You would think that the VFX will be causing issue with the GPU because it's visual, right? But actually, the spawning is handled by the game thread, and it's not looking very good. It's spawning a lot. This is one frame again. It's spawning a lot of these guys, and even by that, if we click here, we will be sent here, and you can see it's 91. And in this frame alone, it has 384 of them. And that's a lot. And if we go for like one of the final frames, and yeah, we need to go to the Galaxy Impact again, we will notice that this time is a lot more. And if we do here, if we just go like this, we'll see there a lot more, right? This is after shooting for a while. So not only they spawn a lot in one frame, for example this frame, right? They spawned here, and at next frame there is nothing, right? Because it's not really spawning anymore. It's not really spawning, it's already spawned. But you see the render thread is a lot busy right here, right? And if we do like this, this is waiting. The render thread is waiting because they are spawning, and then the render thread is doing its own things. But even when we're not shooting, right, the game thread is still busy with some of them. So they're in memory, basically. If we go here, we can see, for example, here on this frame, I don't believe we were shooting, but there's a lot of them now. And every time you shoot, they become more and more and more and more. It becomes ridiculous, right? And there are 1,800 here. So they are left in memory. And to see that even easier, I know the VFX name, but you can see it here as well. It's called Galaxy Mana. So if I search for Galaxy Mana, and I believe it's the impact, right? We can even see that this is in the GPU, but it's still affecting the CPU. So it's definitely spawning, the spawning. So we can see how it's used. So I think there is this VFX placed on this map, and there is this projectile, but we're we want to check the first person projectile. Let's see how it's spawned. So we have event hit, and this is when the projectile hits, right? And it activates this one here, which is mana impact, but on top of that spawns like 100 of this. So we have a loop, and for each of these it spawns one. That doesn't look efficient. And for example, if we decide to spawn only one, let's say we do this, right? Actually, before we do this, I want to show you another way you can actually see it very clearly. We can go to this one just to have it faster, and we're going to use a new tool. This is for Niagara, so we can profile the particles. What we can do is go to Windows, Tools, Debug, and Niagara Debugger. So we need to have this open here. And when we're in the game, get the command and type Niagara Debug HUD. It's like here on top. If I place this, it will get me all the Niagara system that are in memory right now at this moment. So currently we don't really have much. So if I get this and I hit it, you will see that we have 101. If I do it again, 200, because as you remember, it's spawning, right? So they're left in memory. And if I do the stat unit, and yeah, as you can see, it's just getting worse, simply because they are left in memory. And you see the megabytes in memory, and you see the emitters and what is active, what is not. You have scalability, particles, yeah, all that. So if we exit, and let's say we don't want to do this loop because it's ridiculous, right? We don't want to spawn 100 of them, but we want to spawn one. And let's do that again. Just type Niagara debug. Okay, so it didn't work because I believe I closed it. So let's do it again. Let's try. So let's get the weapon. And now it's a little bit better, right? But still, if we do it a lot, they are left in the memory. It's not as worse as 100 at a time, but they're still left in the memory. And ignore the game chat again. This is why you need to profile in the standalone version. But yeah, it's not looking good even now. Why is that? Well, we are still spawning it, but we're not destroying it. So a better method to do this will be to use just this, to activate it. We have the first person projectile, right? And we have a component that is Galaxy Mana Impact. The auto activate is not on, and it activates when we hit something, and it will just activate this one, this VFX. So if we do it like this, we have the Niagara debugger, if we do it like this now, it is over, right? They are not really left in memory, which is nice. For that, of course, you need to destroy it. I have a timer here, delay, and then destroy the actor. So this is a way to optimize this particular issue. So next I'm going to show you a little bit more of the optimized viewports mods and how you can use them to how to debug and to profile stuff inside the editor rather than playing the game. As I said, this is not the best way to do it. It's good to use Unreal Insights or use the GPU profiler, but let me close the Unreal Insights. But let's say you want to just have a look really fast what is going on your scene, and you don't want to make a build or like wait for the standalone game to come. So if you just need to have a quick overview of your scene and how it looks from optimization point. So as we saw, the light complexity is pretty good. Blue is good, so that's because we have only one light in the scene, which is directional light. There's no complex thing going on here, so this should be good. Again, this is for lighting, but we don't have baked lighting, so this is useless for us right now. Shader complexity, you can see there are stuff you can optimize. This is basically the shader and how complex your shader is. For example, this is a decal, and decals are pretty expensive, as you can see. It's red. At least it's not white or pink, but it's still red. And if you have a lot of decals on the ground or everywhere, you have these red things appear, right? It's not that optimized, but it's not the worst thing right now. And you have shader complexity with plots. This is basically the geometry, shows you the shader complexity and the geometry. For the GPU, it's of course geometry is a factor, but with the modern GPUs, not that much, but still it's good to see. So next I want to show you something interesting. If we go to optimization viewport and require texture resolution, and everything will become a little bit gray. And let's say I want to select this here and this object and go to texture, and let's say I select this texture, and now we're going to see something interesting. As you will see here, this color coding here basically shows you if the texture is over its resolution or it's under. So for example, if I go close to here, it will become red. So at this point, at this distance, this texture is 2 times less than it should be. So for example, if this texture is 520, it should be 124, right? Sorry, 512, it should be 124. And here is the opposite. From this distance, if this texture is for example 124, it should be 520 at this distance. Basically it shows you at certain distance is it good or not. So white is good, so at this distance this texture will look good, and at this distance this texture will look extra good. So you can optimize it. If you're going to see, for example, you will never go close like this, you can optimize it and make it a lower resolution. For like twice as low. And we can select anything, for example, here we can see. And when we select the texture, it will show everywhere where it's used, right? And maybe here, like that, look, there's a lot. So this is how you can actually optimize the textures and see if your textures are good or not. But most of the time this is very green unless you go like this, right? It will become very red, but at this distance I think it's okay because your player is like that. And yeah, this is how you can see your textures and see if they're good or not. This one looks actually a little bit low resolution, but for the purpose I think it's perfect because you're not going to ever look at it at this distance. You're looking at it like this. So how can we optimize this further? Well, it's very simple. We need to find the next bottleneck. So let's actually play the game. We can save it. So I'll open the game and wait for it to open and get back to you. And we're back in the game again. Start unit. And we're looking kind of good. The draw is a little bit high. And let's try to figure out what is the issue? What can we improve here? We can do Control Shift and Comma to open the GPU visualizer, but what we can do is test if there's issue with the GPU. If we do screen percentage, our screen percentage, it's here, and we can do 10. So we immediately saw our GPU GPU time going down, but the frame MS, like the frame, didn't really move that much. Let's see, 100, it did move, but yeah, depending on where you are, I guess. But yeah, this is 27, and when we do 10, it dropped a little bit, and the GPU time drops as well. So let's do it again. So what does this do? This basically makes your resolution 10 times lower. If you do it to 10, it's 10% of your resolution. And this is a neat trick that you can use to see if the GPU is the issue. If you make the screen percentage 10, you will see if you still have a bad FPS, you will see that it's not the GPU, because currently the GPU creates a lot less pixels on the screen than before, and it shouldn't really, if the GPU is the problem, it should reduce, it not reduce, but it should increase the performance significantly, because it's 10 times less things that it should do. Yet the performance is not decreased significantly, and as you can see, the draw is kind of the problem here. And what can cause this issue? Let's exit the game. Actually, before we exit, we can do this, and let's do another GPU profiler. Just to see. So we have the bottlenecks here are the diffuse, shadow, depth, direct, diffuse, indirect, and AO, and this is lumen. So the next bottleneck is lumen again, even for the GPU. And what does the render thread does? The render thread prepares everything for the GPU as well as calculation for the lights. So what we can do is check the render thread if the issue is there, right? And we know it's kinda lumen because it says lumen there. And if we go to post process, the easy way to figure out if it's lumen or not, we can just disable lumen and play the game again. Disable the reflection, disable the global illumination, your scene will look not that good, but you will see if the performance improved, and if it does improve, it's lumen. So next thing is to optimize it. So now if I go to start unit, we have a little bit better. This is about 60 FPS, a little bit less, and it plays a lot better. As you see, the draw is a lot less, the GPU is also, so basically lumen is the final boss of this scene, right? So let's try to optimize it a little bit. So we had these settings before, right? Let's see what happens if I just reduce. You can see the effect, right? So this is really like a matter of what you need and from visuals and performance, but this is how you can actually optimize it here. Like, you can make a lot of details or not. So let's, for the sake of this, just optimize it a little bit. And I believe 4000, or for example, if I go 2000, you see how here it becomes a lot like more of what it was without lumen, but you can have something in between, and we don't need to touch this. And we have the lumen reflections. We can decrease the quality if we want to optimize it more, and there is the bounces and the roughness. You can see like this. It doesn't trace roughness at all, or it traces it a lot. We can put it to the default. And let's see if our optimization did anything at all. So let's play the game again. So we are in the game, and if we bring start unit, it's for sure not 16 ms, but we did optimize it a little bit, and even if we move and go around, it is a little bit better, and the visual is not that much different. There is some noise for sure, but yeah, at this point you need to think, do you want to sacrifice from your visual fidelity from the lighting, or you want and have a better performance, or you want the full visual fidelity but your performance will be a little bit worse. So yeah, this is the final point. In this video we tested and profiled and solved different issues, but we just went over the most common ones and easier ones to profile. There are a lot more complicated ones, and we can go a lot more in detail with the different things. For example, we didn't touch much on materials. We didn't really touch on draw calls and how we can optimize that. There are a lot of stuff that can be talked about optimization, but this video was something like introduction and how you can optimize some of the most common stuff. And yeah, I'm going to create more videos, and I'm going to focus on other stuff. For example, Niagara optimization, material optimization, blueprint optimization. We need to talk about HWOTs and nanite as well, to see the different things we can do to optimize the scene. But for now, this is an introduction to optimization. I hope this was very helpful, and if it was, please leave a comment or like, or both. I enjoyed doing these videos, and I'm trying to get back more into creating videos. There will be some visual things like VFX creation as well, not just technical, but I just wanted to focus on a little bit more technical issues, as some of you may be struggling with your project and how to optimize it. So this is a very common thing, and we need to have at least some knowledge about it. So I hope this was helpful, and see you in the next one.